All right, so we're going to go over what we've learned so far in Chapter 10. I'm going to do this formula sheet a little differently because I want to talk about the commonalities and the differences between the strategies and the types of inference that we're going to be using. So this time, instead of going and doing all of 10.1 and then coming back and doing the same thing for 10.2, I'm going to go across this way. So let's talk about the symbols for the parameter for the population of the three things that we have talked about. For difference of proportion, it's going to be the true population's proportion from the first sample minus the true population's proportion for the second sample. And this is the difference in proportions. And then the difference of means, we're going to do the true mean of the first sample minus the true mean of the second sample. But over here, when we do mean difference, this is our paired data. So this is our paired data. So when we do, we're only going to be looking at one mean, and that's going to be of the difference in the two times or the two whatever you do. Sometimes you'll see maybe me be a little lazy and do mu sub d, and the capital D stands for the difference in the means. Well, the mean of the differences. I said that wrong. All right, so this is the difference of the means. This is the mean of the difference. So remember how when we did paired data, we subtracted the two and then we found the average of the differences. So the difference in the two populations means, this is the mean of the single sample of differences. All right, so the symbol for your statistics here, so your proportions is going to be p hat 1 minus p hat 2. The symbol for the statistics for your difference of means is x bar 1 minus x bar 2. And then the symbol for your statistics for the mean difference is x bar of your differences. All right, the name of the procedure is a two sample z something for proportions. And what you would do is, we can do test or intervals. So you do a two sample z test or a two sample z interval. All right, and then for the difference of means, same thing. Two sample t blank for means. So you're going to do a two sample t test or interval. And then for the name of the procedure for your paired data is a one sample t procedure for means. And again, you're going to put a test or an interval here, depending on what the question is asking you to do. All right, your condition. So for proportions, we have our random condition. So we need our simple random sample. We have our 10% condition, which is independent. So remember, you're going to do the 10% condition for both groups. And then normal, you're going to do N1 times P hat 1, N1 times 1 minus P hat 1, N2 times P hat 2, N2 times 1 minus P hat 2. Just remember that you are checking successes and failures, and they all have to be larger than 10. For the normal condition to be satisfied. Okay, so the next two conditions are the conditions for the difference of means and the conditions for the mean differences. They are going to be the same. So I'm only going to write them down one time and span them across both boxes. So if you know the population is normal, then you know that Oh, hang on, let me back up a second. So the random and the independence conditions are also true here and here. So you're still going to check random and independence the same way. But just remember independent, I'm going to write this right here. Independence for experiments, it requires random assignment of treatments. So you wouldn't do a simple random sample, and you wouldn't do the 10% condition. So if you have a randomized design, the random conditions met. If you have the random assignment of treatments, the independent conditions met, and you won't have to check the 10% condition. So what I'm going to do in these two boxes is write down what the normal condition is, because that's the only one that's different from proportions. So to check normal, the population is normal. If the population is normal, our normal condition is met. If our sample size is greater than or equal to 30 by the central limit theorem, our sampling distributions are normal. And if n is less than 30, we need no strong skewness or outliers. And please remember for these two, this is for 2 sample, you have to check these conditions for both samples. So the population would have to be normal for both of the 2 samples. Both samples have to be greater than or equal to 30 to use the central limit theorem. If both samples or one of the 2 samples is less than 30, then you have to graph it and check for your strong skewness or outliers. But if you're doing the difference of the mean or the mean of the differences, then you only have 1 sample to check. So you don't have to do both, you just follow this. But if you have 2 samples, you have to do this twice, one with each sample. All right, so the formula for the mean of the sampling distributions for proportions, the mean for the difference in the sample proportions is going to be the true population proportions mean, true population's proportion for the first sample minus the population's proportion for the second sample. So the formula for means, for the mean of the sampling distribution for the difference of means, so mu of x bar 1 minus x bar 2 is going to be mu 1 minus mu 2. And then the mu for the difference in the samples averages is going to equal the true mean difference. All right, the formula for the standard deviation of the sampling distribution. This is going to be sigma, because notice it says the standard deviation. This is not the standard error. I'm going to write that down in just a minute. So the standard deviation of p hat 1 minus p hat 2 is equal to the square root of p1, 1 minus p1 over n1, plus p2 times 1 minus p2 over n2. The standard deviation for x bar 1 minus x bar 2 is the square root of and then the standard deviation for the mean difference and that came from chapter 9 when we were doing test of significance and intervals. I guess it came from chapters 8 and 9. formula for your confidence intervals. Remember on your formula sheet, it's going to say, oh, by the way, all of these are on your formula sheet. And we don't have these specific filled in symbolic formulas for confidence intervals on your formula sheet. Remember, you have statistic plus or minus your critical value times your standard error. So for the confidence interval for proportions, the statistic is p hat 1 minus p hat 2 plus or minus the critical value for proportions is z star. And then we do our p hat 1, 1 minus p hat 1 over n1 plus p hat 2, 1 minus p hat 2 over n2. Remember, we do not pull here. Do not pull. Standard error. Now, just because we're talking about pooling, I'm going to go ahead and fill in the formula for the significance test. So again, this is not on your formula sheet, but you will have the words. So it'll say test statistic equals your statistic minus your parameter divided by the standard deviation. And so to fill that in, and remember, all of these formulas here are on your formula sheet. So you can just utilize these words to kind of plug and chug the symbols as you need to. So your formulas for your significance tests for proportions, it's Z. So your statistic, if you'll look, it's right here, p hat 1 minus p hat 2 minus your parameter, so p1 minus p2. This is usually 0. It doesn't have to be. But, oops, you can't see, sorry. It's usually 0, but sometimes it might not be 0. If you want to see a problem where it's not 0, I think it's like number 66, because I was looking at that one yesterday in chapter 10, and that one doesn't use 0 for the parameter. It uses a different number if you're interested. But I believe in these day and times, you're going to be using 0. You'll be using 0 way more often than you'll be using another number. All right, so statistic minus parameter divided by the standard deviation. Now, this is where we have to pool our data. So we have to do p hat c, 1 minus p hat c over n1 plus p hat c, 1 minus p hat c over n2. Now, this is on your formula sheet, that p hat c is your number of successes, x1 plus x2, divided by your sample sizes combined. So this one is on your formula sheet. Okay, so you can use this formula to find these values for p hat c and all that good stuff. Okay, so let's come back up here and let's do the formulas for the confidence intervals for the difference of means. So a 2 sample. Now I'm going to change colors just because I went over here and I don't want you to be confused. All right, so the statistic, x bar 1 minus x bar 2 plus or minus your critical value, which is t star, times the standard error, which is right here, s1 squared n1 plus s2 squared over n2, all under the square root. And then your test statistic for means is t. And again, it's going to be your statistic, which is x bar 1 minus x bar 2 plus or minus, oh, not plus or minus. That was confidence intervals. minus the parameter, so mu1 minus mu2. Again, this number is usually 0, but it doesn't have to be. Divided by the standard deviation, which is S1 squared over N1 plus S2 squared over N2, and that is all under the square root symbol. All right, so now looking at the mean differences. So these are the one sample. So this goes all the way back to the one sample stuff that we learned in chapters 8 and 9. All right, I grabbed my formula sheet because I want to make sure you remember that you have these formulas on here. So here is the formula for one sample for means and, oh, that's slope. One sample for proportions. So you have these in your formula sheet where it says one population or two populations. So you'll use whichever one depending on the way the problem is set up or what the problem is asking you for. All right, so you would do X bar of the difference plus or minus your critical value. So since we are talking about means, we're going to use T star, and it's going to be times the standard deviation of the statistic of the differences divided by the square root of n. And then your test statistic is still T, and it's going to be your statistic, so X bar D minus your parameter, the true mean of the differences, divided by the standard deviation. So the standard deviation of the sample divided by the square root of n. So if you need a refresher on these are chapters 8 and 9, because that's where we did one sample stuff. All right, how to find your p-value. So I'm going to put how to find your p-value in the calculator, just to have down what buttons you need to press. So we're going to be using our calculator, which I have a lot to say about the calculator, but I'll save that for another one. So how do you find your p-value for the difference in proportions? So you're going to press your stat key. So you're always going to start with your stat key, and you're going to go over 2 times to tests. All right, so go over 2 times to tests. Oops. Stat over 2 times to test. And so for our 2 samples difference of proportions, I need to find a 2 prop z test. So number 6 is a 2 prop z test if you're asked to do a confidence interval. And then B is the 2 prop z interval. So number 6 will give you the p-value when you run the test. It'll give it to you on the last screen. And I know that this is not your p-value and this probably doesn't belong in this box, but I wanted to put the 2 types of inference methods that we will be using. I want to put that in that box so you can see them. All right, so now let's do means. So again, we did stat 2 times over to tests. So we got a 2 sample t-test. So number 4 is a 2 sample t-test. And then a 2 sample t-interval. So that's number 0. 2 sample t-interval. Remember, we will never, ever, ever, ever use z for means, because that means if we use a z-test or a z-interval for means, that means we know the true population's parameters, which would then negate the reason for having to run the test of inference. So those are only there to help you find sample sizes, and you will never run a test using a z for means, only for proportions. All right, and then the mean difference, you will either do number 2 that just says t-test, or you will do number 8, which says t-interval. And again, I know these don't all go in this box necessarily because it says how to find p-values. So of course this top, the test will help you find the p-value, but I wanted to also make sure you know where the intervals are as well.